Good day everyone, I'm your presenter for today's lesson in physical science, May Kayla Lopez de la Cruz, here on May Kayla TV. If we heard the word physical science, what is the meaning of it in your own perspective? Okay, physical science is the study of matter and energy that covers a lot of territory because matter refers to all the stuff that exists in the universe, includes everything you can see and many things that you can see. So meaning that physical science is a branch of natural science that studies non-living systems in contrast to life in science. So physical science explains everyday observations and actions. So what might be some ways that physical science influences our lives? So for example, we depend on physical science for just about everything that makes modern life possible. So for example, you cannot turn on a light, second, make a phone call, or use a computer without centuries of discoveries in chemistry and physics. Physical science can be divided into chemistry and physics. So when we say chemistry, is the study of matter and energy at the scale of atoms and molecules. And while physics is the study of matter and energy at all scales from the tiniest particles of matter to the entire universe. So meaning to say that chemistry is a branch of science that deals with the properties, composition, and structure of elements and compounds, how they can change, and the energy that is released or observed when they change. So when we say physics, it is a natural science that studies matter of physics is one of the most fundamental scientific disciplines, and its main goal is to understand how the universe behaves. And now let's proceed in the physics of sound. So sound is a pressure wave which is created by a vibrating object. This vibration set particles in the surrounding medium or the typical air in a vibrational motion. So those transporting energy through the medium. So we have the traveling waves, transverse waves, standing waves, interference, and overtones. First, we have a traveling waves, a wave in which the particles of the medium move progressively in the direction of the wave propagation with such a gradation of speeds that the faster overtake the slower and are themselves into turn overtaken. Compare standing wave. There are two types of wave motion for mechanical waves. We have longitudinal waves and transverse waves. So the longitudinal waves are the class of waves in which the particles of the disturbed medium are displaced in a direction that is parallel to the direction of the propagation of the wave, also known as the P waves or the primary waves. In an earthquake are examples of longitudinal waves. The P waves travel with the fastest velocity and are the first to arrive. Next, we have the transverse waves. Transverse waves is a moving wave that is made up in oscillations happening perpendicular to the direction of energy transfer. So the S waves, also known as the secondary waves, in an earthquake are example of transverse waves. S waves propagate with the velocity slower than primary waves or the P waves arriving several seconds later. Next, we have the interference. When two waves meet, there can be two kinds of interference patterns, constructive and destructive. So the effect is the addition of the amplitudes of the individual waves at each point affected by more than one wave. The two kinds of interference patterns, we have the constructive interference and destructive interference. So when we say constructive interference is when two waveforms are added together. So the peaks add with the peaks and the troughs add with the troughs, creating the louder sound. While the destructive interference, it occurs when two waves are out of phase, the peaks on the line out with troughs on the other. Next, we have the standing waves. also called a stationary wave, combination of two waves moving in an opposite direction, so each having the same amplitude and frequency. The phenomenon is the result of interference, that is when waves are superimposed, so their energies are either added together or cancelled out. Next is the transverse waves. If a string that is fixed on both ends and bowed or plucked, such as a violin, vibrations are formed that are in a standing wave pattern. So having nodes at the fixed ends and then the antinode in the centers, the several harmonics are also produced in a similar way to the standing wave. And last, for the overtones. So the overtones are the other frequencies besides of the fundamental that exist in the musical instruments. So the instruments of the different shapes and actions produce different overtones. So the overtones combine to form to the characteristic of sound of the instrument. So what are the importance of sound waves? So we all know that the sound is really important in our lives. So without sound waves, human beings could not communicate verbally. That's right, yes? So your vocal cords generate sound waves that are then transmitted through the air to the ears of listeners. So modern communication technologies such as radios and televisions use the same basic concept to transmit sound to your ears. That's all. Thank you for your listening.